Hi there, I'm Eleanor from the KU Natural History Museum, and this is Pop-Up Science Online. I don't know about you, but I love to make art with beautiful colors and bright colored paints, markers, and inks, and finding just the right color to achieve my desired effect really helps to communicate my artistic vision. If you enjoy making art too, I bet you've wondered, just like I have, how are these colors made? The paint and ink colors that we see are a combination of reflected light from differently colored molecules. And you can separate out the individual types of color molecules from the mixture to reveal their unique colors using a scientific process called chromatography. Today, in this episode of Pop-Up Science, we're going to explore paper chromatography. I'm really excited about today's program because my friend Colleen will be joining us and she'll show us how to conduct a paper chromatography experiment at home. For step-by-step instructions for today's activity, head to our Museum from Home website and click on the Pop-Up Science tab, where you will find a downloadable PDF with all the instructions. Before we go to Colleen though, let's talk a little bit about the history of chromatography. Chromat comes from the Greek word chroma, which means color. Graphy comes from the Latin graphia, which means to write. Because chromatography is about separating a chemical's molecules into layers that often appear as colored lines in the filter material, that is where the chemical technique gets its name. The development of chromatography is one of the major revolutions in the history of chemistry. A Russian botanist, Mikhail Tsvet, invented paper chromatography in the early 1900s during his research on plant pigments. Although his discovery was initially ignored by fellow scientists, it later became an important method that was improved upon and used in many different science fields, from analyzing the contents of food and drink, to exploring the chemical bases of DNA, to analyzing fossil fuels like petroleum, and even performing forensic analyses in crime labs. Without chromatography, scientists may not have been able to synthesize insulin for the management of the disease diabetes, or understand how plants make food through photosynthesis. In chromatography, the separation of a substance into its component parts is based on the way those components become distributed or partitioned between two different phases. Recall that there are three phases of matter: solid, liquid, and gas. Because there are different phases, scientists can analyze chemical substances using gas to liquid chromatography techniques or liquid to solid chromatography techniques. Colleen is going to tell us about the paper chromatography technique, which is a type of liquid to solid analysis. Although paper chromatography is not used by scientists as often nowadays as other later developed forms of chromatography that have better separating power, such as thin layer chromatography, which uses gel, paper chromatography is still a really useful way to demonstrate the analytical method for separating out the component parts of chemical substances. Let's try it out for ourselves with Colleen.
Thank you so much for that amazing background, Eleanor. Hi everyone, my name is Colleen and I am going to demonstrate how to do a paper chromatography experiment, and you can join me. Do you ever want to paint with a certain color, but you just don't have it? It happens to me all the time. For example, I want to paint the color purple, but all I have is blue and red. What am I going to do? Well, I can take those two colors and I can mix them together, because the mixture of a red and a blue paint makes purple. So I can mix and mix and mix those two paint colors together and get the color purple. Now, once I mix those colors together, I can't separate them again. But in some cases, scientists can take chemical mixtures, so chemicals that are made up of a lot of different parts, and they can separate them into those different parts. Do you know of any ways that a scientist could do this? Chromatography is a technique used by scientists to separate mixtures of chemicals like inks, dyes, and even food colors. There are different methods to separate different mixtures: liquid chromatography, gas chromatography, thin layer chromatography, and paper chromatography. Each of these phases has a stationary phase and a mobile phase. What do you think I mean when I say a stationary phase? A stationary phase is the phase that doesn't move. So what do I mean when I say mobile phase? Well, the mobile phase is the movement, specifically the movement of compounds through the stationary phase. In this activity, we are going to focus on paper chromatography. Paper chromatography uses capillary action, or the flow of liquid, in this case up and against the force of gravity, to separate a sample into different parts. The stationary phase in paper chromatography is the paper. The mobile phase is the sample that separates. In what ways do you think chromatography can be helpful? Why would a scientist need to separate a mixture of chemicals? Paper chromatography can be used to separate inks, and I want to experiment with paper chromatography using food colors. Now, before I start my experiment, I want to generate a hypothesis. A hypothesis is an educated guess, or what I think is going to happen in the experiment based on what I know about paper chromatography and color mixing. So the question that I'm trying to answer with my hypothesis is, will the paper chromatography experiment indicate the food color is made up of a mixture of different colors, or that the food color is made up of only one color? Now, for my experiment, I think that some food colors, like this purple gel food color, will separate and show that they are made from a mixture of different colors. I think that some other food colors, like this blue food coloring, will not separate because they are not made from a mixture of different colors. So let's experiment together to see if my hypothesis was correct. And before we start, I also want you to create a hypothesis on your experiment.
Now that you have generated a hypothesis, make sure you gather all the materials you will need for the experiment. You can find a complete list in the activity guide on the website. Take the coffee filter. Cut 2 strips 3 inches in length from the coffee filter. If you have a ruler, you can use it to measure the strips. If not, estimate the length of the strips to the best of your abilities. Measure 1 inch from the bottom of the strip of coffee filter and use a pencil to mark that measurement. If you have a ruler, you can use it to measure the mark. If not, estimate the length of the mark to the best of your abilities. Attach a strip of the coffee filter onto the middle of a popsicle stick using tape. Repeat on the second strip. Label the popsicle sticks with the food color that will be tested on the strip of the coffee filter. Then, put a drop of food color on the appropriate strip. Fill each cup with a salt water solution made up of approximately 200 milliliters, or about 3/4 of a cup of water, and 1/8 teaspoon of salt. Mix the solution with the spoon to make sure the salt dissolves. Rest the popsicle sticks on the rims of the cups. The filter paper should hang down and just barely touch the solution. Some of the food color may fall into the saltwater solution. That is okay for this experiment. Wait approximately 5 minutes for the paper chromatography experiment to occur. Once the water has traveled to the tops of the papers, remove the sticks with the papers from the cups and place them on a sheet of white paper. Let's study the results together. Compare and contrast the results of this paper chromatography experiment on the 2 different bottles of food color. Do the results indicate that the food color is made up of a mixture of different colors? Or do the results indicate that the food color is made up of only one color?
How do the conclusions gathered from the results relate to the hypothesis? We can conclude from our observations that the purple gel food color separated into at least 2 colors, blue and pink. The purple gel food color is made from a mixture of at least 2 colors. The blue food color did not separate into different colors. Therefore, the blue food color is not made from a mixture of different colors. The blue food color is made up of just one color. Now, what does this have to do with your experiment? If you use different food colors, or if your hypothesis was different than mine, what do you think about your hypothesis now? Did the experiment support the hypothesis, or did the experiment have results that were different from your hypothesis? We started this activity by mixing colors together, and then we did an experiment using paper chromatography where we separated a mixture of colors. In what ways do you think chromatography can be useful? All right, I'm going to send you back to Eleanor. It was so much fun doing this experiment together. I'll see you soon.
Thank you so much for joining us today. I hope that you had fun learning about chromatography and trying that experiment with Colleen. We would love to see the results from your experiments, so please post pictures of how the colors separated on your filter paper in the comments below or tag us on social media. Stay tuned for next month's Pop-Up Science program on September 12th, where I'll take you on an exploration of our live reptile exhibit, and we'll learn about some of the unique adaptations that snakes and lizards have. Bye-bye!